Trickling filters. Process description. Biological process, fixed film system trickling filters. I know at my plant we used an air stripper column, which is filled with like little plastic cages, and water rains down or is pumped down through, and we blast an air blower at it. That's air stripper column. All right. Wastewater sprinkled over a fixed media process with slime and biological film that coats the media surface. A film consists of bacteria or protozoa and fungi that feed on wastewater organics. Film requires continuous supply of dissolved oxygen. Adequate ventilation required, natural ventilation or forced air. Media voids must be kept open. Flow is usually intermittent. Quality of film produced is controlled by the available food. Remember what I was talking about with BOD? Increases as organic load increases until maximum effective thickness. During operation, film will slough off. Effluent recirculation increases treatment efficiency. All right, so this is a distribution system. Distributes water from the top of the media, fixed distribution system, intermittent liquid dosing to provide rest periods, rotating distributor. And the media types are rock, which is approximately 35% void space, and plastic media, approximately 95% void space. And the underdrain collects filtered water and provides ventilation. Classification of filters: standard rate media. It usually rock media 6 to 8 feet deep. Hydraulic loading of 25 to 100 gallons a day per square foot. Organic loadings is 5 to 25 pounds per day per 1,000 cubic foot. A high rate. The media is rock 6 to 8 feet deep. Synthetic 15 to 30 foot deep. Hydraulic loading is 100 to 1,000 gallons a day per square foot, and synthetic is 350 to 2,100 gallons per day per square foot. Organic loading, rock media is going to be 25 to 100 pounds per day per 1,000 cubic foot. Synthetic media is going to be 50 to 300 pounds a day per 1,000 cubic feet. And generally, all high rate trickle filters use recirculation. Roughing filters. A high rate filter with very high organic loading. 100 to over 300 pounds per day per 1,000 cubic feet. Used to reduce organic loading to subsequent oxidization process. Abnormal conditions. Ponding. Results from a loss of open area in the media bed. The causes of ponding are excessive organic loading, lack of primary clarification, improper media selection, and accumulated fibrous material filling the media voids. Odors. The aerobic process. No serious odors should exist. Foul odors indicate anaerobic conditions. Filter fly. Tiny gnat-sized fly, or Cicoda, are most frequently found in low-rate filters because that has time to pond up. So that's why that happens. To control, increase the recirculation rate. Apply approved insecticides. Flood the filter. But flooding the filter results in a poor effluent quality and should be carefully monitored. Or you can apply chlorine dose. Sloughing. Excessive film loss is an indication that there are problems with the biological activity within the filter media. Rotating biological contactor. Biological process, fixed film system rotating biological contactor. A fixed film system similar to trickle filtering. Media. The media is moved through wastewater. So instead of letting the water drip down, this one moves the media through it. A rotating shaft surrounded by a plastic disc called media. Slime grows on the plastic media. As the media drum rotates, media is alternately submerged in water and exposed to air. So it lets the water sit in there and it rotates around into the water, which is why these are sideways. And you can guess the water level is somewhere either just below it, kind of like a swamp cooler. All right. It's generally covered for reasons relating to weather conditions. So if it's like raining, windy, or snowing, yeah, they'd want to cover that up. Maybe not so much when it's windy. Protects slime from freezing. Prevents rain from washing the slime from the media. And to avoid exposure to sunlight. It prevents growth of algae and prevents deterioration of media. Yeah, so that's why it's covered. Provides some protection from operations from sun, rain, snow, wind, and etc. during maintenance. Principles of operation. Process operating conditions. Performance is affected by hydraulic loading and temperatures below 55 degrees Fahrenheit. Typical operating and performance characteristics. Hydraulic loading. BOD removal, 1.5 to 6 gallons per day of square foot of media. Nitrogen removal is 1.5 to 1.8 gallons per day per square foot of media. Organics loading, soluble BOD is 2.5 to 4 pounds per day, or 4 pounds of BOD per day per 1,000 square feet. BOD removal is 80 to 95%. Effluent total BOD is 10 to 30 milligrams. Effluent total BOD is 10 to 30 milligrams per liter. Effluent soluble is 5 to 15 milligrams per liter. Effluent NH3N is 1 to 10 milligrams per liter. And effluent NO3N is 2 to 7 milligrams per liter. Free treatment requirements, usually proceeding by screening and grit removal and primary settling. Abnormal conditions decrease treatment efficiency. Possible causes are temperatures are below 55 degrees Fahrenheit, large variations in flow or BOD loading, and unusually high or low pH level, biomass sloughing, and the possible causes are influent contacting toxic or inhibitory substances, unusual variation in flow or organic loading, snails, not a problem in RBCs used for BOD removal, generally occur in plant providing nitrogen removal. Snail shells may clog pipes and pumps. Snail control is chloration, or to increase the pH to 10 to kill the snails without harming the microbial growth. Process description. Activated sludge process. Uses microorganisms to speed up and decompose waste. Microorganisms feed and grow on waste particles in the wastewater. As organisms grow and reproduce, more and more waste is removed. Mass of organisms needs a steady balance of food and oxygen. Principles of operation. Process description. Oxidization and removal of soluble or finely divided suspended materials. Anaerobic organisms stabilize material by partial oxidization. Process forms carbon dioxide, water, sulfate, and nitrate compounds. Remaining solids change to a form that can be settled and removed during sedimentation. Process objectives. Conservation of dissolved and suspended material to settleable solids. Oxidization of organic waste. Classification process. Complete mix. Contents of aeration tank are completely mixed. Organic loading. Mixed liquors suspended solids, or MLSS, is between 2,000 to 5,000 milligrams a liter. Contact stabilization captures a mix or captures of waste material and digestion of that material is done in different aeration tanks. Organisms capture waste material in a contact tank or reactor. Settled organisms are returned to the re-aeration tank to digest the captured material. Organics loading. Mixed liquor suspended solids, or MLSS, 15,000 to 2,000 milligrams per liter, or 1,500 to 2,000 milligrams per liter. Sludge wasted to maintain proper process control.